My AC decided the middle of July would be the time to break. I do have a fan going on high because it's really, really hot right now. I hope the noise from the fan isn't interfering with the sound on this video. So we'll just have to kind of play it by ear. It's been a rough couple weeks, y'all, but here we are. We're wrapping up. Okay. So for section 11.4, we need to talk about something called a hyperbola. Okay, so just a really quick shape reference, a hyperbola is going to look like this. That's a little bit too fat there. So like this. So that's a hyperbola. Or you could have a hyperbola that's oriented the different direction. So you can have either of those as a hyperbola. Now, as for a definition, we have that a hyperbola is the set of all points in a plane whose distances from two fixed points in the plane have a constant difference. So that basically means we have these two fixed points. We know from an ellipse that these fixed points, we call them a focus point. So foci for the plural, okay? So we have these two foci points, okay? And with an ellipse, we were looking kind of at the distance from a specific point on the ellipse to the first focus and then to the second focus. Well, we're kind of going to do something similar to that. So let's say that we're looking at this parabola here, okay? And let's say we have a focus point here and here. We'll call these focus 1 and focus 2, okay? Well, what we're talking about with this definition is the distance from the first focus point to some point on the plane, and then the distance from that point on the plane to the second focus point. Okay. If we were to subtract these distances, we would always get the same thing, no matter what 2 points we pick. Okay. So let's do two more. Let's do pink and then like a light blue. So let's say we have a point here. Maybe not that point. Let's do a different one. Let's do a point here. Okay. So we're looking at the distance from the first focus point to that point on the plane. I just realized I labeled both of these focus point 2. So we'll say this is focus 1 and then the blue one's focus 2. And then let's look at this color. So from that point to focus 2, if we subtracted pink minus blue or red minus blue, we're going to get the same difference. Okay, so no matter where we're at on this plane, we're going to get the same difference between those two distances. Okay, so we have these points. We'll call this x1, y1. We'll call this x2, y2. Doesn't matter what point we have on the plane, when we take the distance from the first focus point and subtract the distance from the second focus point, we always get a constant distance. Okay. Now, we're going to see what that constant distance is in just a minute. Now, some additional definitions. We know the fixed points are the foci, which is just plural for focus. So those are the foci of the hyperbola. We also have a line segment through the foci. So when we were talking about an ellipse, we had what we called a major axis and a minor axis. We have two things that are very similar. And honestly, I don't know why in 1487 all the mathematicians didn't get together and be like, hey, let's use the same names. They didn't. Okay, but what we need to know is there's some kind of axis that runs through those focus points, and it is called the transverse axis. So that is very similar to the major axis with an ellipse. And then there's a center. So the center is the point like right between the two curves. There's another axis that runs through that center perpendicular to the transverse axis called a conjugate axis. Okay, so we've got a transverse axis, we've got foci. You'll sometimes have the transverse axis called the focal axis. I will probably mistakenly call it the major axis or the transverse axis. Okay, we have a center, which is between, it's going to be halfway between the two curves. So it's going to be halfway between the two focus points in your hyperbola. We have the conjugate axis, which is a line segment perpendicular to the transverse axis that runs through the center. We also are going to have vertices. So remember when we were dealing with an ellipse, we also had vertices there. Let's use green for the vertices. So the vertices are going to be the points where the hyperbola intersects the transverse axis. Okay, so the vertices These are the points where the hyperbola intersects the focal axis or the transverse axis. But then we also have what are called covertices. And the covertices are a little bit different. They're going to be on your conjugate axis. And I'll explain what those are when we actually start looking at problems. It'll be a little bit easier to see. But they're going to be points that are on the conjugate axis. They're the same distance from the center, okay? They're not actual points on your hyperbola, which is a little bit different. So we have vertices, those are actual points on the hyperbola. And then we have these covertices, which are just these, they're very important points, but they're not actual points on the hyperbola. They're just points kind of on your conjugate axis, okay? So as a recap, let's look at a very busy drawing, okay? So you can see we kind of have these navy blue lines that represent the actual hyperbola. You can see the vertex points, the focus points, you can see the co-vertex points, and you can see the center. Now, what I want to show you here with the co-vertex points is hopefully you can see that they've kind of created this rectangle here. And every time I draw one of the hyperbolas, I will always draw this rectangle because hopefully what you can see from this image is that hyperbolas are asymptotic. That means there's going to be asymptotes. So they're going to get really, really close to these lines and they're just going to kind of follow that general direction forever. They're not going to cross it. And so we have these asymptotes here and here. And what's really nice is we can create this box, this like rectangle in between the two curves of the hyperbola, and those asymptotes are going to cross through the corners of that rectangle. Okay, so it makes it kind of nice and helpful to draw. Okay, so you can see a lot going on here. You have your transverse axis, which is this red line in the middle. So let's follow that one. I'm going to make it a little brighter. So we have this transverse axis right here. We have the conjugate axis right here. We have our vertices here, whoops, here and here. We have the focus points here and here. We have the co-vertices here and here. And let's not forget the super and ever important, let's do yellow, center. Well, that's not yellow, is it? The center here. Okay, so we're going to do kind of like we did with an ellipse. We're going to look at the definition. We're going to figure out some really important pieces. We're going to find vertices. We're going to find foci. We're going to find asymptotes. We're going to do the whole bit. Okay, now we a minute ago I told you that when you're dealing with a hyperbola, regardless of what point you have on the hyperbola, the distance from that point to the first focus minus the distance from that point to the second focus is always going to be the same distance. It's always going to be a constant distance, okay? Well, down here, we get a little insight into what that distance actually is, okay? So we have yet another definition of a hyperbola. It's the same thing. It's saying the same thing, just kind of in a different way. It's saying a more formal definition is that a hyperbola is the collection of all points P, so just ordered pairs P, such that the difference of the distances from P to the foci is plus or minus 2a. So do you remember when we were talking about an ellipse, we had points A, B, and C? We have the same thing here. So let's talk about what those points are, okay? So when you're dealing with an ellipse, okay, not an ellipse, a hyperbola, we still have A, B, and C, okay? We just need to be really careful about what A, B, and C are, okay? So A is the distance from the center to either vertice or vertex point, okay? So this is negative A, this is positive A, okay? We then have the distance from the center to the focus points. That is C, okay? And then the co-vertices, the distance from the center to those co-vertices, that is B. So let's just kind of pretend here. Let's pretend that we had co-vertices here and here. We would say this distance would be plus or minus B. Okay, so we're going to have that whole A, B, C thing happening again. And the distance from the first focus point to a point on the hyperbola, and then minus the distance from that same point to the second focus point is always going to have a length of plus or minus 2a. So basically the distance between the two vertices is equal. That's going to be the distance. So like if we take the distance, let me write it out. If we take the distance from focus 1 to a point minus the distance from focus 2 to the same point, it's always going to be 2a, or the distance between the vertices. And it could be negative depending on where those points are. It might be that the distance from um, the first focus to the point is shorter than the distance to the second focus. And so you can get plus or minus 2a, but you're going to basically get that distance between the two vertices. Okay. Now I do have a short animation, and then I think we're going to go ahead and end this video there. So let me show you the animation. It's not as good as the animation that we had for an ellipse, but it gets the point across. So you can see here, as we move the point on our hyperbola, the distance from the first focus to that point is either getting bigger or smaller. And then as it's getting bigger or smaller, the point from the distance from that point to the other focus is getting, bigger or smaller. But regardless, the distance between, or the length between those two distances is probably a better way to say it, is always going to be plus or minus 2a. So there you have it. That is the introduction to a hyperbola. Like I said, it's been a rough week. I am absolutely blazing hot right now. So I know these videos maybe don't have the whiz bang, but I'm just trying to get through them. All right. So next up, we're going to look at some examples.